This video will guide you through the basic setup of the DS user interface for real-time monitoring of dynamic signals. Please view the previous video to learn how to set up DS. We begin with the setup from the previous video. We have 3 dynamic signals, signal 1 through signal 3, and 1 speed parameter. We will begin by looking at the engineering plot layout. The test stops panel will be shown afterward. The first thing to be done is to configure the plot layout for the current page. Click the main plot window. Clicking on the arrow box changes the grid pattern. We'll define a 2x2 grid since we have 3 channels and speed. Click on the first window of the plot area if it's not already selected. Select the signals you want to create plots for on the plot data tree. DS has an all channels feature to make this easy for large channel counts. Notice how DS automatically selects all channels. From here, you can pick one of the plots from the plot types tree. Here we create time domain plots. Notice that one plot is created for each signal. Each plot is scaled to the default ranges provided in the setup. You can easily overlay the signals on a single plot if you select more than one trace per plot at the bottom under Traces per Plot. Here we have 1 signal per plot since we selected 1 trace per plot. Now we will add a speed history trace to the lower right plot. Expand the plus sign next to parameters and select our only parameter, N1. Your setup could have many parameters, especially if you use our parameter server interface to a low-speed data acquisition system. Parameters are slowly varying or low-speed signals. Selecting history under the plot types tree produces the plot. At this point, we can begin monitoring signals in real time by clicking the monitor button at the top of the display. Notice how all the plots begin to immediately update and the system clock begins to increment. Now we will create another page of plots. Click on the up arrow on the page selector to create a new page. You can keep DS running as all plotting setup can be done dynamically. We will create another 2x2 grid and make another set of plots for each signal. Select the first plot window and again select all channels from the selector tree. This time we will pick the N1 speed parameter from the X-axis data value tree. Under plot types, expand arrow mechanical by clicking on the plus sign. Now select Campbell. DS will create 3 Campbell diagrams as a function of speed. Note that if you didn't select speed, DS would create Campbell diagrams as a function of time. Any parameter can be used for creating Campbell diagrams. Also notice that the Campbell diagrams are immediately beginning to update. We will again create a time history plot of the rotor speed N1 in the lower right. You can change the plot settings for these or any other plots by right-clicking or by selecting the Control tab above the plot data tree selector. This will allow you to modify scales or other plot settings interactively. Changes can be applied to all plots. All plots on all the pages continue to update as the test runs. Campbell diagrams are fully interactive. Here we click on the frequency axis to create a frequency tracking plot. To return to the Campbell diagram, right-click and select Revert. Plots can be minimized or maximized by double-clicking on the axis area of the plots. Now let's look at the Test Operations panel. This panel is designed for the test operator to be able to view all channels and parameters on a single page, and to control data acquisition and disk usage. DS automatically scales the test ops panel so that all signals and parameters fit on a single page. Because we have only 1 parameter and 3 signals, the display is automatically reconfigured to a 2x2 grid. A log is provided along the left margin. All the plots are updating in real time. Also, the system tells the operator that no data is being recorded. This is because we turned off the monitor files in our initial setup. Double-clicking on any of the plots in the Test Operations panel will maximize the plot and provide detailed spectral information as well as additional parameter information. Overrange signals will be shown by changes to the background color of the plot. This concludes our tutorial. If you need any additional information, please refer to the DS help documentation or contact us at info@apexturbine.com.